So in section 3.6, we're going to be using the derivatives of logarithms to help us do more complicated problems and or more fun problems. From pre-calculus, hopefully you remember these rules. For the log of an a times b, you can break that up into two logarithms as long as you add them. When you're dividing a divided by b, you can break that into two logarithms as long as you subtract. And if this is an exponent on the a, you can bring it in front and multiply. So that's the review from pre-calculus. Now, one other thing is, if you have the natural log of something, and then you take the derivative. So it would be y prime equals the derivative of the natural log, that is 1 over whatever's in the parentheses. So 1 over a. And then you'd need to do the chain rule, take the derivative of a, so multiply by a prime. The reason I'm pointing this out is because it's easier to just do that all in one step and say the derivative of natural log of a is going to be the derivative of a divided by a. It's the same thing, but it just goes a little bit faster. And when we've got quite a few logarithms, it's nice to have this little shortcut right here. Okay, then for example number 1. How about if the function is the natural log of x squared plus 7x divided by 2x plus 5. Now you could just go ahead and start taking the derivative. So it would be 1 divided by this, and then do the chain rule, take the derivative of this, which means the quotient rule. Or you could use these rules, especially this one for this example. And what you can do is you're basically taking one complicated problem and you're breaking it into two easier problems. So that's what I'm going to do here. So before doing the derivative, just use the rules of logarithm. And this is going to be the natural log of x squared plus 7x. And then minus the natural log of the bottom, 2x plus 5. And now that we've done that pre-calculus part, we've now got two easier functions to deal with instead of one big one. So now take the derivative. And I'm going to use the little shortcut that I just mentioned. The derivative of this will be derivative of the inside, so that's going to be 2x plus 7 divided by what's in the parentheses. And the first one is done. Minus the derivative of the inside would be a 2 divided by 2x plus 5. And in just 2 steps, we're already finished. Then for example number 2. How about if it's y equals x to the x? So this one you cannot use the power rule. If it said x to the 7, you could use the power rule. If it said x to the negative 1.4, you could use the power rule. But with the x as a variable, you cannot use the power rule. So what we do is take natural log of both sides, and then use that third rule, which says this exponent, you could bring it in front and multiply. So the right side is going to become x times the natural log of x. All right, now it's time to take the derivative. So on this side, it's going to be the derivative of the argument divided by the argument. On the right side, we get to use the product rule. So the derivative of x is 1, and then leave natural log of x alone. And then plus, leave x alone and take the derivative of this natural log of x, which is going to be 1 over x. Then we've got 2 more steps. One is to solve for y prime, multiply both sides by y. So it's going to say y prime equals y times the natural log of x. And then this is going to reduce to just be plus 1. The last thing is, I know that y is equal to x to the x, so I'm going to replace that right here. So my final answer sitting in this beautiful little box right here, is that y prime equals x to the x times the natural log of x plus 1. So sometimes the natural log will already be in the problem. Sometimes you need to take natural log of both sides. So for example number 3, how about y is equal to 5x plus 3, that's to the 13th power, x squared plus 5, that's to the negative 9 power, and 2x plus 1, that is going to be to the second power. So if we were to do this one without using logarithms, we would need to use the product rule. Because the product rule is for only two things at a time, what you need to do is group them and say this is one thing and this whole thing is the second one. And then start doing the product rule. And when you're in the middle of the product rule, you'd have to take the derivative of this, which then means you're doing the product rule within the product rule. It's possible, but it would be better to use logarithms. So take log of both sides. And because these are multiplying, I can break this into 3 logarithms, log of the first one plus log of the second one plus log of the third one. So natural log of 5x plus 3 is to the 13th plus the natural log of x squared plus 5 is raised to a negative 9, and plus the natural log of 2x plus 1 is squared. And before I take the derivative, I'm going to take these exponents and move them down in front and multiply. So then the first one is 13 times the natural log of 5x plus 3. The next one is going to be negative 9 times the natural log of x squared plus 5. And then the last one is 2 times natural log of 2x plus 1. Okay, after that pre-calculus part, we're now ready to do the calculus part, take the derivative on each side. For this one, it's going to be the derivative of y divided by y. For this one, the 13 could just sit there while I take the derivative of this. And you take the derivative of the argument divided by the argument. Then the negative 9 can just sit there. The derivative of the inside is 2x divided by the inside, x squared plus 5. And for the last one, it's going to be derivative of the inside is 2 divided by the inside, 2x plus 1. All right, we're almost done. Now I need to combine these numbers, so that is going to be 50 and 15, that's 65. Also, I'm going to multiply both sides by this y so that I get just y prime equals. This is going to be 65 over 5x plus 3. Then minus, this will be 18x over x squared plus 5. And this one will be 4 over 2x plus 1. And then I just need to replace this y. So take this, what y equals, copy it, and paste it right there. When I do that, I'm not going to leave that negative exponent. I'm going to put that in the denominator. So my final answer, hopefully it will fit on the page, is, so recopy this as y. So 5x plus 3 is raised to the 13. And then I'm going to move this one to the denominator. X squared plus 5 is to the 9th in the denominator. And then there's also 2x plus 1 is squared. All right, that replaces the y. And then this other part, just recopy it and we're done. So it takes a bit of writing, but the work itself is not bad. You're right, we should do another one. Okay. For example number 4. So find the derivative in 2 different ways. Also, plug in a 1 and find out what the derivative equals at x equals 1. So the function is the natural log of the square root of x. Since I'm doing it 2 ways, I'll label it a and then b. A, I'm just going to go ahead and start taking the derivative. Y prime equals, so it's got to be the derivative of the inside divided by the inside. The derivative of the inside would be 1 over 2 times the square root of x. Divided by the inside is the square root of x. And this we should simplify. So I'm going to eliminate this, which is causing a compound fraction. So multiply the top by 2 square root x. Multiply the bottom by 2 square root of x. And so y prime is equal to, so on top these would cancel, it would just leave this 1. And on the bottom, the square root of x times the square root of x will just be x. So it's 1 over 2x. When you plug in a 1 for x, that means that the derivative is going to equal a half. Now before I go on to part B, I want to use the calculator and see if I got it right. So go to y equals, clear out this old problem, and type in the original function, which is the natural log of the square root of x. And then I'm going to go to zoom standard, and the function basically looks like the natural log function. And then I'll go to second calculate, and number 6, take the derivative. Then plug in a 1, and it says you should have gotten a 0.5. So I got 1/2, that's the same thing. And then for part B, how about if we do it a different way? So start off with this. Then what I could do is rewrite the square root as x to the 1/2. Now use the rule from logarithms that says you can take this 1/2, move it in front, and multiply. All right, that's the pre-calculus part. Now the calculus part. Take the derivative, it'll be 1/2. The derivative of natural log of x is 1 over x. And so when you multiply these 2 fractions, that gives you 1 over 2x. And of course then, we get the same answer. Well, that's it for the derivatives with logarithms. I'll see you in the next section.